Okay, let's continue with binomial distributions. Okay, what is binomial distributions? The probability problems that have two possible outcomes, or they can be reduced to two outcomes. Okay, example of the two possible outcomes. For example, we have a coins. So coins only we have two, head and tail. So this is we call it as a two possible outcomes. Or a baby is born. So baby is born whether it is a boy or a girl. So only two possible outcomes. Okay. So binomial experiment is a probability that satisfies this requirement. So the first requirement is about each trial can have only two possible outcomes. Okay. Let's say success or failure, or coins, head or tail, baby, boy or girl. Okay, second one is there must be a fixed number of trials. Okay, the third one, the outcome of each trial must be independent of each other. And the fourth one is the probability of success must remain the same of each trial. Okay, so let's take a look on the notations of the binomial distributions. So PS for the symbol of the probability of success. So PS here is a probability of success. PF, probability of failure. P is the numerical probability of success. Q, the numerical probability of failure. So PS is equal to P. PF is equal to 1 minus with P is equal to Q. Okay, so here, if P plus Q, the total must be equal to 1. So if the questions only give you the value of P, so meaning that you can get the value of Q by 1 minus with P. When 1 minus with P, so meaning that is equal to Q. Okay, so meaning that here P plus Q equal to 1. If the equations just telling the value of Q, so meaning that you can search for the value of P. Okay, and then N is the number of trials. Okay, number of trials. And X, number of success. So X here can be 0, 1, 2, 3 until N. Okay. So let's take a look on the formula of binomial distribution. Okay, so binomial distributions, here we have by. By meaning 2. Okay, apart from binomial distribution, we also have multinomial distributions. So here is multi. So multi means many. So when you look at your slides, okay, slide number 25. Okay, the multinomial distribution is similar to the binomial distribution, similar. But allow one to compute probabilities when there are more than two outcomes. So you just remember like this, binomial, two outcomes, multinomial, more than two outcomes. Okay, so let's take a look on the formula. So for the formula, for the binomial, we have n factorial divided by n minus x factorial, and then x factorial times with p power of x times with q power of n minus x. Okay, for the multinomial, it's actually the same as binomial. In binomial, we have only n here and then n minus x. Okay, for the multinomial, we have n factorial divided by x1 factorial, x2 factorial until xk factorial. Okay, so here we have p power of x times q n minus power of n minus x. But for the multinomial, p1 power of x1 times p2 power of x2 times p3 power of x3 until pk power of xk. Okay, so binomial, instead of this formula, binomial have the other formula. It's the same formula actually. It's the same. This one and this one. So you can memorize either this one, this formula, or this formula. Okay. For the second formula is n c x. Okay. Times with p power of x q power of n minus x. Okay. So binomial distribution also has the mean, variance and standard deviation formula. So you can see that the mean formula is equal to mu equal np, variance equal to npq, and for the standard deviations only add the square root for n times with p times with q. Okay.